Ciao, welcome back to the channel. I'm Luca, your Android engineer, and in today's video, we're taking a look at how to implement REST API in your Android project. This is a feature that basically every app uses, connecting to the internet and requesting data from the internet. And I don't see many tutorials that tells you how to do that step by step. There are two main ways to do REST API over the internet within an Android project. Both of them imply using a library. The most known library and most used library in Android is Retrofit that uses OKHTTP. The other one is Ktor, which is a library that is gaining a lot of momentum right now because of its support for Kotlin multi-platform. Let me know down in the comment if you'd like me to go through the same thing that I'm going to show you today using Retrofit instead with Ktor and maybe in an KPM project as well. Here I have a project that I just created. It's a empty activity project that just show a greeting. This is the standard structure of a new Android project. The first thing we want to do is open our Android manifest, and inside the manifest, but not inside the application tag, we want to use a user's permission, and we want to use the internet permission. This is because to create API calls on the internet, Android requires you to specify inside the manifest that you're going to use the connection of the user phone. The next step would be to add the libraries that I spoke you about in the Tom version file. We will need to add two libraries, and so two version as well. One is for Retrofit and one is for a converter, which will help us convert the JSON that we will get back from our REST API calls into data that we will use in our project. Next up is to declare those two libraries as well with Retrofit and Retrofit JSON using the choose version that I just declared. Let's now sync our project in order for us to be able to use and reference those two new libraries from our build Gradle file. Once the sync has finished, we can add the implementation for the two libraries that we just defined in our libs version Tom file. And again, let's sync the project in order for us to be able to reference those new libraries inside of our project. Those two implementations will need to be placed in the module that will use the connection to the internet. In this case, since it's a tutorial video, I'm just defining them in the app module file. But if you have a clean architecture structure in your project, you might want to define those inside the data layer of your project in order to not declare those dependencies in the app where you don't need them. The Retrofit libraries work with a Retrofit instance and what's known as API services. The Retrofit instance allows you to specify the base URL for your endpoints that you will need to query. The API service instead is the class that will let you create the request to a specific endpoint. Let's create a new package and call it data, where we will create everything that we will need for the network module. We will then create a new class, which will be our network module, and this will be an object. Inside of this object, we want to create an instance, which will be of the Retrofit class. We also want a function that returns the instance, and we want this instance to be a singleton. To do that, we can check if the instance is initialized. If it's not initialized, we want to assign a Retrofit. To create an instance of Retrofit, we can use the builder. And the builder function has a build function that lets us create an instance. And then we can return the instance. This way, whenever we need an instance of Retrofit, we can just do network module get instance, and this will return the unique instance of the Retrofit. The Retrofit builder also has a base URL function that accepts a string where we need to define the base URL of the website or the API service that we're gonna query. To get started, I just searched on the internet for a free API service and came across the daily cat facts because we're on the internet and cats are cats. So we're gonna use this website to get some endpoints. There is a documentation that gives us the base URL for all the endpoints, and then the website provides us with two endpoints: facts to retrieve and query facts, and user to get user data. User requires authentication, and this will not be covered in today's video. We're just gonna use the facts endpoint here. It also provides us the module structure, one for the fact and one for the user. Let's now copy the base URL and provide it here inside the base URL parameter of the instance of Retrofit. The next step that I would suggest you to do is to create a class that represents the data that you're going to receive from the internet. So let's go ahead and create a data class, which we'll call fact entity. And this fact entity, we need to know what parameters we're going to receive as part of a fact when we query the fact endpoint. So let's go back to our website and open the facts endpoints. To get some random facts, we can query the /facts/random endpoint with a get. And we can provide two query parameters. One is the animal type and one is the amount. And we can see that this is an example of a request. And this is the response that we're going to get. So if we query two facts, we're going to get a list of two facts, with each fact being this one, selected now on the screen. We will have an ID, a V, a text, an updated at, which is a string, a deleted, a source, and a set count. So we want to create a data class that represents that data. Here I just copy pasted a piece of code that I had ready. As you can see, I'm using the SerializedName from the JSON library in order to specify what is the name of the parameter that we're going to receive from the internet. I'm using SerializedName here for several reasons. The first one being that you can specify different name in your data class compared to what we receive from the internet. This is useful. As you can see here, the __v represent the version of the fact. We don't want to save a parameter which is name __v because the IDE tell us that property name should start with a lowercase letter. Another thing is that if you want to replace something in your code base, for example, I want to replace the parameter version with version code. If I do a Command-Shift-R to replace in the entire project and change version to version code, in this way, the name of the parameter that we're receiving from the internet is not affected anyway from the refactor. Another thing that might happen is, for example, the updated at or set count might come from the internet in another format. Right now it's coming with the kebab case, but I've seen many providers returning a snake case as this one for now in set count, and we don't want our variable to be named this way, because again, the IDE will give us a warning. Once we have our data class ready, we can define the API services that will query the endpoint and return us this data. So let's create a new class. We actually need an interface, and let's call this API service. Inside this API service, we can use a notation and create function that defines each of the endpoint that we want to query. We've seen here that the random fact endpoints is a get. Retrofit library gives us an annotation, which is the get, that accepts a string, which is the URL of the API service that we're gonna query. And going here, we can see that the endpoint is /fact/random. So let's copy and paste it here. And now we can specify a function. And Retrofit comes with direct support for Kotlin suspend function. So we can mark the function as a suspend function. And we can say, call this function as getRandomFact, accepting no parameter. And the return will be a fact entity that is the class that we defined previously. Now we can see here that the amount default to 1 and the animal type default to cat. So we don't need to specify them, but we might want to. If we want to specify them, we can recreate another one, which will be always get random and facts, and then another one, get random facts. And we can specify, for example, the animal type, which will be a string, and the amount, which will be an integer. And this one instead will return a list of fact entity. So since those are query parameters, we can use other annotation that Retrofit gave us to mark those two parameters as a query parameter. We can use the query annotation and provide the name of that query for each of those parameters. So for now, we need, here it is, a pretty example that uses next case animal type, but we don't want to call this parameter animal_type. We want to call it animal type. And then the other one is amount. So calling this one will default to calling this one with animal type cat and amount 1, whereas this one we can set the int. To prevent this function to call the random fact with just amount being 1, which will return a fact entity and not a list of fact entity, we can use another annotation, which is intRange, that allow us to specify a from. So we can specify that it's gonna go from 2. So the minimum integer that we can provide here is 2. There are other type of REST API. For example, there is the post API, the patch API, the delete API, and the put API. We're gonna see those ones, or at least the post one, in following video tutorials. But for now, let's focus on just the get that will return our data. Now that we have an API service, we need a way to get the API service in order to call the getRandomFact or getRandomFacts from wherever we need them. Let's go back into our network module and create another function that returns our API service. Use the getInstance class and create function, which is a function from the Retrofit library. We need to specify a class here. So let's specify the API service.class.java. We can now mark those as private, since usually you don't need an instance of Retrofit and access to the actual instance from outside. You just need to interact with an API service. Now, a common thing used in Android project is an interceptor. An interceptor lets you intercept every API, outgoing and ingoing, in order for you to do something in the request and in the response that you're getting. One of the most used scenario is a logger interceptor. A logger interceptor will print in the logcat the outgoing request and the incoming response for your API calls. The logging interceptor is not provided already, so we will need to add its version and its library definition in our Tom catalog. We need a logging interceptor, which is always from SquareUp, OK, HTTP3 logging interceptor. Let's sync the project in order to be able to use this library in our build module file. Once the sync is done, we can go in our build module file and get the library logging interceptor and sync the project in order to be able to use the components of this library when we need them. We need to now create an instance of our logging interceptor. So let's go with a val logging interceptor, which is an HTTP logging interceptor. And to change anything here, we can use the apply function and set the level to HTTP logging interceptor level and body. We have other level at our disposal. We have body, headers, basic, and none. And there are some example here. For example, the basic will just print the endpoint and the response. The headers will print the same, and also the headers and the body will print everything that we query and everything that we receive back. To use this logging interceptor, there isn't a direct way in Retrofit and in the Retrofit builder. To do so, we will need to create an HTTP client and then use the .client function in the builder and set it to our HTTP client. To create an HTTP client, we have the HTTP client builder that let us, for example, build an instance, but also let us add a network interceptor where we can provide our logging interceptor. This way, wherever we need to intercept our request and print them in the logcat, this will do it for us. One thing worth to mention is that you might not want the logging interceptor to be enabled in your release build. For that, we want to create a builder here and not build the instance. And for example, remove the client as well. And here we want to check if our build config is of the type debug, and then we want to add the client. So we want to do client, HTTP client, and then our instance will be our builder.build. Here you can see that the build config.debug is erroring. This is because we need to enable it from our build config file. To do so, we want to use the build feature build config true. And after rebuilding the project, we can use the build config debug. This way, we're gonna log our API request only if we're running a debug app and not in the release that we're gonna release to the store. Now that we have everything in place, we have a way to get our API service and use it wherever we need. Since this is an example project, I'm going to retrieve the API service from our main activity. This is usually not something you want to do. You want to use the API service from a view model and then provide the activity with the data that you need. Let's create our API service instance using the network module get API service function. Given a fact returns a text, which is the fact itself, we want to display the text parameter in our activity. To do so, we will need a few things. First, a loading state that represents the state where the API call is being made, and then a text that is used to write the text itself on the screen. So let's create a var loading by remember and use a mutable state of, and this will be a boolean, and also the same will do to create a text by remember mutable state of, and this will be an empty string to start with. Now you can't do API call on the main thread, so to detach from the main thread in Compose you need a coroutine scope. So let's obtain a coroutine scope by using the remember coroutine scope function. And then we want to use the coroutine scope.launch function. But to do so, we need a launch effect that will use units. So this will be run only once. And then let's move the coroutine scope.launch inside of our launched effect. The first thing we want to do here is set the loading to true. And then we want to get our response by doing API service.getRandomFact. This will return a fact for us. So we actually can use the fact here as well. And now another thing I suggest you to do is wrap every API call with a try catch and catch any exception that might occur. So let's say that we got a fact successfully. We now want to set the text to the text of the fact that we just received. If something went wrong, let's say we want to set the text with something went wrong. And after that, we can use the finally to set the loading to false once again. Now inside our scaffold here, let's remove the greeting function and use a box that will fill the size, and also the content alignment will be centered. And let's also use the padding here and use the inner padding provided by our function. Inside of this box here, we want to check if the state is loading and use a circular progress indicator just to show that something is loading. If instead is loaded, we want to write our text in a text. And let's also text align center. So to center the text that we just got. This way, if we run our application, the first thing that will happen is that we're gonna try to fetch a random fact. And if we get it, we will set the text to our text variable that is used in a text. Let's now run our application to see this working. One thing I forgot we need to do is to add a converter factory. This will allow the Retrofit instance to convert whatever we get into our data. So we need a JSON converter factory because we are getting back a JSON body and we need to convert the JSON body to the fact entity that we declare. With this done, if we run our application, you see that the logcat already is shown. The text of the random fact that we got is simply number, but we can see here that we got the logging of our random fact. This is the query, the request that we sent, and this is the response that we got back. And as you can see, this is the body that we got back. We get the ID of the fact, the text, the type of cat, it's not deleted, and when it was created. Now, let's say that instead of this get random facts, we want to get a list of random facts. So to do so, let's change the text to text, which will be a mutable state of list. And then we want to use the get random facts and change this one accordingly. Now here, we want to provide the animal type, which will be a string, and the amount, let's say we want 5 facts. The animal type, we just can go with cats as it is the default, but we can also use multiple with a comma separated. So let's actually copy cat and horse from the example in the website in order to get 5 facts about cat and horses. Now here we want to change our text to our fact, and let's map the fact to the text. Let's keep the loading set to true and set to false, And now here, instead of a single text, we want a lazy column. And here we want to use our items function with the text that we have. And then we can use the it parameter to write the text that we get for every fact. Now we can rerun our application and we should see 5 random facts printed on the screen. And here they are. We got our response, which is, as you can see, an array of facts. And everything went well, and we got 5 random facts. Cats, cats, cats are dogs of animals. This is the last fact that we got, and then 4 facts that I can decipher. If you know what those facts are telling us about horses or cats, which I don't know to be honest, let me know down in the comment the translation of those texts, and it will be much appreciated. So that's all for today's video. I hope you enjoyed the video. If you did, please consider giving it a like and subscribe for more content. In the next following video, we will switch the endpoint in order to use a more extended endpoint that will allow us to send not only get request but also post request to our endpoints, and the service that we will use will also require us to use an API key that we need to provide in the headers of every request. So we will create a custom HTTP interceptor that intercepts the request at the header with the API key and sends the request. So we will see some more customization and a deeper dive into how to properly use Retrofit to create requests to API services. Till the next time, peace.